Ayşe Önal ARAL. I'm a pulmonologist and I have been working at a hospital in Ankara. In this video, I will talk about the studies in the literature carried out on the use of artificial intelligence in the field of the respiratory disease. Artificial intelligence simply refers to intelligence implemented by computers. The main component of AI is machine learning. It means machines are trained on available data to learn a specific task. The number of studies on using AI in healthcare is increasing in parallel with the developments in innovative technologies in the field, promoting its application in practice. AI can help physicians with monitoring, evaluation, diagnostic process, and treatment decision. AI is used in healthcare through smartphone applications, wearable tools with monitoring equipment, and robots. I have chosen some studies from the literature conducted on the use of artificial intelligence for respiratory diseases. I will especially highlight the result of the studies in order to give an idea of how AI could be used in this area. The first study I will talk about was conducted to classify fibrotic lung diseases using high-resolution computed tomography scans with the evidence of diffuse fibrotic lung disease. For this purpose, researchers developed a deep learning algorithm. The algorithm provides equally prognostic discrimination between usual interstitial pneumonia and non-usual interstitial pneumonia diagnosis. Researchers concluded that high-resolution computed tomography evaluation by a deep learning algorithm might provide low-cost, reproducible, near-instantaneous classification of fibrotic lung disease with human-level accuracy. Also, they stated that these methods could be useful at centers where thoracic imaging expertise is scarce. In addition, that it could be used for stratification of patients in clinical trials. This is important because making differential diagnosis between usual and non-usual interstitial pneumonia is a challenge for clinicians for many times. In another study, researchers developed a deep learning-based automatic detection algorithm for tuberculosis screening using normal chest radiographs and active pulmonary tuberculosis patients' chest radiographs. The algorithm showed significantly higher performance in both classification and localization compared to all groups of physicians. Researchers found that their deep learning-based automatic detection algorithm demonstrated excellent and consistent performance in the detection of active pulmonary tuberculosis on chest radiographs. Also, it outperformed physicians, including thoracic radiologists. As a result, this algorithm may make it easier for physicians when they screen patients for tuberculosis, in particular in the regions where tuberculosis infection is common. In this study, researchers aim to develop and validate a deep learning-based automatic detection algorithm for malignant pulmonary nodules on chest radiographs. Then, researchers compared its performance with physicians, including thoracic radiologists. At the end, they found that this deep learning-based automatic detection algorithm outperformed physicians in radiograph classification and nodule detection performance for malignant pulmonary nodules on chest radiographs. Also, it enhanced physicians' performances when used as a second reader. Given the fact that pulmonary nodules is frequently seen on chest radiographs, the result of this study is promising in terms of diagnosing malignant pulmonary nodules early. In the other study, a computer algorithms that scan chest X-rays and flag images that are suspicious for containing a moderate or large pneumothorax were developed. They found that their algorithms were able to detect the majority of images showing a moderate or large pneumothorax. And researchers interpreted that these models may provide a high specificity screening solution to detect moderate or large pneumothorax. In another study, researchers aim to develop a deep learning-based algorithm that can classify normal and abnormal results from chest radiographs with major thoracic diseases, including pulmonary malignant neoplasm, active tuberculosis, pneumonia, and pneumothorax. And researchers found that this algorithm consistently outperformed physicians, including thoracic radiologists, in the discrimination of chest radiographs with major thoracic diseases. So it demonstrated its potential to improve the quality and efficiency of clinical practice. This study is about lung cancer screening using low-dose chest-computed tomography. Researchers developed a deep learning algorithm that uses a patient's current and prior computed tomography volumes to predict the risk of lung cancer. The model performance was the same as radiologists. They concluded that they showed the potential for deep learning models to increase the accuracy, consistency, and adoption of lung cancer screening worldwide. This algorithm may help physicians with the diagnosis of lung cancer, that is one of the most common diseases among patients with cancer. In this study, researchers aim to explore the accuracy and inter-rater variability of pulmonologists when interpreting pulmonary function tests compared with artificial intelligence-based software. And they found that the interpretation of pulmonary function tests by pulmonologists resulted variations in errors. However, AI-based software provided more accurate interpretations. So they concluded that AI may serve as a powerful decision support tool to improve clinical practice. In this graph, we can see that AI is better than pulmonologists with the higher sensitivity and positive predictive value in the interpretation of pulmonary function tests for the disease categories included in this study. This result is important because pulmonary function test is among the most used tests by physicians for the diagnosis of pulmonary diseases. In another study, researchers developed a decision support system for the diagnosis of asthma and chronic obstructive pulmonary disease. They used a set of clinical characteristics like age, gender, sputum production, chest pain, and smoking, in addition to spirometry, in order to detect asthma and COPD. The best performing algorithm resulted in precision of 97.7% for the diagnosis of COPD and 80.3% for the diagnosis of asthma. And they concluded that, especially for COPD, the results are quite encouraging, given the fact that the employed input features are readily available during a regular pulmonology visit. This study is about COVID-19 diagnosis on chest-computed tomography. Researchers developed a novel deep learning-derived machine learning classifier using a simplified programming approach in an open source data set. Then the diagnostic performance was evaluated and compared to experienced radiologists on an independent testing data set. And they concluded that accurate diagnosis of COVID-19 using a basic deep learning approach is feasible using open source computed tomography image data. This study is a multi-center study about screening of COVID-19 pneumonia. The researchers aim to develop a deep learning-based method to assist radiologists to fast and accurately identify patients with COVID-19 using CT images. Researchers concluded that, based on deep learning method, the proposed diagnosis model showed great potential to improve the efficacy of diagnosis and mitigate the heavy workload of radiologists for the initial screening of COVID-19 pneumonia. The last study I will introduce is a systematic review. This systematic literature review included 155 articles on airway diseases, such as cystic fibrosis, lung cancer, COVID-19, asthma, and tuberculosis. In this graph presented in this systematic review, we can see that artificial intelligence software are superior than pulmonologists in the prediction of various airway diseases. In conclusion, the results of the studies I have talked about so far are promising in terms of encouraging further studies on the use of artificial intelligence, as well as its application in practice in the field of respiratory medicine. Lastly, it is important to bear in mind that artificial intelligence can help physicians make clinical decisions, but cannot replace them completely. Thank you for your attention.